All right. So again, we've talked about linear relationships. We've talked about them a lot. We talked about them in different ways. We did the day where we had like the robots and we talked about he has rules, right? And you can change this and change that. And we talked about it in graphing. And we talked about it with equations. And then for me, normally we like hit that hard for 2 weeks and give everyone lots of practice. Because you know what? It's really hard. It's confusing. It's tricky. And because of COVID, instead it's like, all right, well, we're going to do that for a day and then good luck, you know? And that's just not a great way to learn stuff. And it's really not a great way to learn math. It's a tricky way to learn math. So I want to go over it. And basically, I want you to know that for any kind of relationship that we do in this class, which are what we call linear relationships, which just means if you put them on a graph, they make a straight line. It could be anything. It could be how much money you get paid for how much time you work. It could be how far away you are from home based on how long you drive. It could be any relationship at all, but it will make a straight line if you graph it if there's two parts to it. The first part is what we call the constant. And another word for a constant is a starting value or an initial value. So go ahead and type this. I'm going to write some stuff here, and go ahead and type it in the box. We want to kind of have this note in place. So one of the two things every linear relationship has is it has the place it starts, the starting value. The starting value is how much you start off with. And I know that sounds completely stupid, but it's true. And on a graph, it's what we call the Y-intercept. And I'll show you what I mean by that. So if you want to type those two things in that box, that's a good thing to know. When we talk about the starting value, it's how much you start off with. If we were talking about how much money is in your bank account, we could say, okay, we're going to track the money in your bank account, and you're starting off with, I don't know, how much money is in your bank account? You guys have bank accounts? I'm old, so I have a bunch of bank accounts, because like I have the one for like, I pay my bills from and stuff. But like I have like my savings account that I use for like fancy stuff. Like I built this new computer this year, so I have an account for that where I put money in when I get extra money, and when it gets enough, I spend it. And right now in that bank account, I have $40. Not a lot of money, but it's a bit of money, better than nothing, but $40. That's my starting value. It's how much you have when you start off. Does that make sense? It could be, you know, I could decide that I was going to try to gain some weight. I want to get muscly. So I'm going to start, and I could say, right now I'm 195 pounds, and I'm going to track my weight over time. That would be my starting value. Does that make sense? And on a graph, it's the Y-intercept. So if you do a graph, and I will copy this picture so you don't necessarily have to try to draw it. But if this is our graph, that's the starting value. Does that make sense? If we draw a graph, the starting value is where that line hits the up and down axis, what we call the y-axis. That is your initial value. And we sometimes call that the constant. We sometimes call it the starting value. You can call it whatever you want. But does that make sense? Tell me if it doesn't, because I could be like, Calford, they don't understand me, come explain. And then Calford could come explain it. And I could eat bacon. All right, so that's the first thing, is we need to know how much you start off with. And on a graph, we call that the y-intercept. There's a starting value. And then we need to know, from the starting value, how does it change? Oh, he's good. You're hired. I think you all knew what I wanted you to say. Only Julian was kind enough to me. Only Julian took enough pity on me to be like, oh God, just say it. Change. And I appreciate it, Julian. Thank you. Yeah, that's right. So once you know where you're starting, the next thing to know is, how does it change? And so the rate of change is exactly that. From the starting point, which I'm going to call the initial value here because I want you to get used to different words for things. From the initial value, how does the line move? And we usually express this as a fraction. And that fraction, we usually show it like this. We basically say, okay, on the top we're going to move up or down. So we'd say from the starting point, move up or down this much, and then move, what's the other way we have to move? We have to move up and down, and we have to move? Bingo. And if up and down goes on the top, we're going to put left and right on the bottom. And that is how we put a rate of change. And I'm just going to put ROC. It's a fraction. So if we had a graph and the starting value is here and the rate of change was 4 over 1, I don't like that, 1 over 4, then we would say, okay, no problem. I'm going to move up 1, and I'm going to have to move over how much? 4. 1, 2, 3, 4. And that will tell me where the next point goes. And then if I wanted to, I could do it again. I could go up 1 over 4, another point. Up 1 over 4, another point. Up 1 over 4. I can do that forever. But I don't really need to, because once I have 2 points, then all I need to make a line is... All I need to make a line is a ruler. Does that make sense? Once I've got my 2 points, I can just say that must be what the line looks like. All you need to make a line is 2 points. Any 2 points make a line. So the rate of change always says, the top number says go up or down by this much, and the bottom number says go left or right by this much. Now, sometimes they don't write the bottom number. This is something I want to mention. Sometimes they say, oh, we don't need to include the bottom number. If they don't put a bottom number, how much left or right should you move? If they only give you the top number, they tell you how much to move up, but they don't tell you how much to move left or right. How much should you move by? What's a good default move?
1.
Good. Bingo. Does that make sense? Sometimes they give you a rate of change and they don't bother to write the bottom number. If they haven't bothered to write the bottom number is 1. And I'm going to mention that in this note because that's a good thing to know. If there is no bottom number, go left, right by 1. I'm going to highlight that. And that's it. If you know that, you're off to the races. You can draw a line. The only 2 things you need to know, where to start and how to move. Yep.
And you spell it for me.
Oh, of course. Yeah, take your time. You got nothing but time. Is that what you need?
Yeah.
Cool. Yeah, take your time. And I will copy that picture over for you guys so you've got that nice picture to work with. It's not a very nice picture, but it's better than nothing. Do you know every year I ask the board for $20,000 to buy a class set of these so you could all have your own pen and draw on it? And do you know for some reason every year they say no? I don't know why. They don't want to give me 20 grand. But one of these days. Wouldn't that be nice if you could just grab your pen and just draw right on your screen? It's nice for me. I like it. The last thing, by the way, is this. If a line goes up, we say its slope is positive. When I say a line going up, what do I mean? Does anyone still ever play games like Mario Brothers? Like that kind of side scroller where you're just walking? Do you know what I'm talking about? Can you picture that? You know, in Mario Brothers, where on the screen do you start? If I was playing Mario right now, here's the level in Mario Brothers. Where do I start? Right, I appear on the screen. I got to get going. Where do I appear on the screen? Would I appear over here?
The left side.
You start on the left side. And which way do you always move?
Right.
Always to the right. Does that make sense? So if you understand Mario Brothers, you understand graphing. Because we're always starting at the left and moving across the screen. Does that make sense? Unless you're anyone here like a manga head and they love like the Japanese comic books that go the other way. Yeah?
Don't call me out.
You totally are, aren't you? That's not calling you out. You should be proud of that. That's so cool. But you have to ignore that for this. Think Mario Brothers, not manga, okay? Is it manga or manga? I never know what to say.
I call it manga.
Manga? Got it. Okay. So a graph is like that. So if it's a positive graph, it means that the line is going like this. Because if Mario were walking on this, would he be going uphill or downhill? Imagine Mario. Mario's here. Is he going up a hill or down a hill? Beautiful. And so if he's going up, it is positive. On the other hand, if a line goes down, the rate of change is negative. And I want to mention that you're going to see some other words here. Sometimes we use rate of change. Sometimes we use this word. What word have I written here?
Rate of change.
Yep. And it's the same thing as
Slope.
slope. Sometimes you'll see the word slope. That's just another word we use to mean how is this thing changing. So take a minute, write that. There's no rush. You got all the time in the world. But if you know these two things, then you know, then you know how to graph a line. If you know where it starts and how to move it, you're golden. Does that make sense? Cool. Do we have that? No rush. All right, then let's take a look. Here we have an equation, and it says we want to graph a line on here, and what two things do we want to do? We want to have an initial value of
1.
Great. And a rate of change of 1/4. 1/4. Good. Okay, so which one of these do we have to start with? I want to put this on the graph. What do I start with when I want to put something on a graph? I know it's got to have an initial value, and I know how it's changing. So what do I start with?
1 or is it 0?
Yeah, this one starts at 1, right? Very good. Initial value, which can also be called starting value, which can also be called Y-intercept, doesn't matter what they call it, that tells you where to start. And should I put that there? What do we know about initial value? Initial value is where that line hits the up and down axis, right? So if you look down here, we want to put it not here, we want to put it on the up and down axis. And on the up and down axis, I want to find the number 1. Does that make sense? So we find that, and we say, okay, my line is going to start right here. Does that make sense? And you can use the drawing tool if you want, and just put a nice dot there. But can we all see that? That's the first half of making a line. And it may not seem like much, but you've actually done the hardest part. You've started. And in life you will find, whatever you're doing, you know what the hardest part of doing anything always is? Starting. That's what I find. I don't know if you're different, but I find when I've got schoolwork I need to do, like the first 40 minutes of my schoolwork is me sitting in front of the computer going, all right, gonna do my schoolwork. Gonna mark those papers. Time to mark the papers. It's paper marking time. Let's see what's on YouTube. All right, paper marking time. Gonna mark some papers. Let's read the New York Times. Okay, totally time to mark papers. I'm just gonna stare at the screen blankly for 10 minutes. Do you ever do that? I do that. So once we've got that on there, we're halfway there. Now the next thing is, where do we go from here? I could go up, I could go sideways, I could go back. How do I know? Well, we know that the rate of change is 1/4. Now, First things first, is that a positive number or a negative number? 1 over 4. Is that a positive number or a negative number?
Positive.
Yeah, of course. How would we know if it was negative? It'd be? How would I know if it was negative? What would have to be there? Yeah, there'd be a negative sign, right? If it was negative 1 over 4, that'd be negative. But it's not, so it's positive. So since it's positive, this line must be going up. So it goes up. Ooh, the less common spelling of goes with a U. Interesting. That means the line's going to go this way. It's not going to go that way. Does that make sense? We know the direction it's going. And then it tells us how much do we go up and down by. We go up by how much? According to this slope.
1.
We go up by 1. And then we're going to go over by how much?
4.
Very good. So then from here we go, okay, I'm going to go up by 1. And I'm going to go over by 1, 2, 3, 4. And I'm going to draw my next point. Does that make sense? Cool. And then I'm going to go up by 1, and I'm going to go over by 1, 2, 3, 4, and I get my next point. And I could keep doing that all day. But I don't have to do it all day, because now that I've got some points, what can I do with them? Bingo. I can get a ruler, I can draw a line through them, and that's it. If you can do that, you can draw a linear relationship. There it is. So all you need to know to make a graph out of a relationship is you need to know where it starts and you need to know how it changes. Where it starts, how it changes. Where it starts, how it changes. Where it starts, how it changes. Can the first thing I put on the graph be how it changes? Nah, you got to start, right? No different than it would do you no good if you ran the fastest 100 meters anyone has ever run is if you accidentally did it instead of in the parking lot instead of in the track meet, right? You'd look pretty stupid, wouldn't you? If the whistle rang and everyone was like that and everyone ran on the track and you being faster than everyone ran out in the parking lot, are they going to give you the ribbon?
No.
No, not a chance. So you got to know where you start. You got to start in the right place. And once you know where you start, then rate of change tells you go up and over, up and over. So I built a little app here, and it's not much of anything. It's not much of anything, because I'm not very good at building apps, but it's something. And if we click it, and we give it a minute, and we let it load, I might want to make it a little bigger, because the text can be pretty small. Hello. It's cool because this one actually says just the one we just did. That's the one I had it start on. And just like that, I could put this one at 1. I don't know why that just zoomed out. That's weird. That was weird. And then the slope was 1 over 4, right? So I could say, okay, no problem. We're going to go up by 1 and over by 1, 2, 3, 4. Okay, I think I know why. I think it's because I accidentally used, there we go. Okay. And you see how that's what we just did? Well, here's what's cool, right? See this where it says, check your answer? If you click that, it's going to put an orange line on there. And if you're right, well, then you're just going to be right. But if I got it wrong, like now it has a new one for me with an initial value of 3. And this has a slope of, I don't know if you can see that, but it says negative 1 over 2. Can you see that? The fact that it's negative means that this line should be going down like this, right? So it should be going down by 1 and over by 2. So like that, right? Does that make sense? If I check my answer, bingo, it likes it. I'm just going to show you getting one wrong just so you can see. If I get it wrong, then it's going to show like that, right? It's going to show a line different than where I put it. But I like this because you can just do this all day and you can just make sure you understand it. Here's one, initial value of
3.
and a slope of
3 over 4.
Cool. Tell me, what should I do? Where should I start with this?
Start at 3.
I start at 3, so does that mean down here?
No.
No. Always start on the
Up and down.
up and down. So I start at 3, and then am I going up or down with this one?
You go up by 3.
Great. How did you know to go up and not down?
It doesn't have a negative.
Good. So we're going to go up by 3. 1, 2, 3.
And then over by 4.
Over by 1, 2, 3, 4. And there we go. And then I can check it. Bingo. Does that make sense? Believe it or not, that seems pretty simple, right? That's actually really sophisticated math. That's complicated stuff you're doing there. But if you can do that, you're off to a really good start. You're off to a really, really, really good start. So I'm going to leave that there with you. My advice is practice a few until they feel easy. Once it feels easy, once you're like, okay, that's boring, I got it, it's easy, then you're good. But it really is good to get practice. Then there's one other thing I wanted to get you, which is it is nice to have a graph. And you guys live in an era where computers can graph for you, which is super cool, right? Super cool. But I'm going to give you 5 minutes to kind of mess about on that. I want you to get a couple of these right. Try it out. When you get one right, throw your hand up and let me come take a look at it. And I'll be proud of you. I'll be like, you're doing great. Oh, that looks great. Very good. And just so you know, if you click the blue word, it'll open in. Just so you guys know, if you're finding it small, because those screens aren't huge, right?
Yeah.
If you click the blue word here, it'll open in its own window. And just that way you can zoom in as much as you want. Just something to keep in mind, if it matters. Like if it's fine on the screen it's on, that's fine on the screen it's on. But sometimes I find it a little small. So that was good. You did great. Can I see one from you? Awesome. Oh, that's okay. That's okay. You had it. Show me one more. That was good. But you did have it. Yeah, you have it. Well, that's great. Good. Does that make sense? Again, believe it or not. Ooh, can we get one? Okay. So it has to start at -2. So that's okay. So grab your starting thing, and where are we going to put it? Nope. Always on the up and down. Bingo. And then we got to go up by. Okay, so we can just count it out. 1, 2, 3, 4, 5, 6. Good. And 1, 2, 3. Yep, check that. Beautiful. Does that make sense?
Yeah, I didn't.
Awesome. Yeah, remember that initial value's got to be on the up and down. Always on the up and down. That's great. Can I take a look here? Oh, look at you. Killing it. And that feels all right?
Yep.
Awesome. You guys are great. Okay, look up here. That's fantastic. Good for you. God, my job's so easy when you guys are so clever. And I like it. Let's just keep that going. Okay, so now there's one other way we like to give this information. See how here I'm giving it to you as a sentence? I'm saying graph a line, the initial value is 1, and the rate of change is 1/4. All right, that's a sentence. There's another way to say it, which is with what we call an equation. The exact same thing. It literally is the exact same thing. It's just in English we use sentences. And the problem with a sentence is you have to speak English, right? So this sentence is easy for you because you all speak English. If I brought a French student in here, somebody who only spoke French, and I said, excuse me, Jacques, pardon-moi, Jacques. See, I don't speak French. But if I did, if I said, hi, Jacques, graph a line with an initial value of 1 and a rate of change of 1/4. Jacques might be amazing at math. How's he going to do with what I just said? Probably not so hot, right? Because he doesn't speak English. And if it was written down, he'd know the number 1 and he'd know 1/4, but he doesn't know what example, graph, line, these are all different words, right? So Jacques not going to do good. And he might be able to figure it out because at least like in French, example is exemple, things are pretty similar. But what if Jacques were Japanese and they don't even use the same alphabet we do? Or if you were Russian or Greek, they use different alphabets. How's he going to do with that? Terrible, right? He doesn't have a chance. So in math, we said, okay, can we design a way to say that exact same sentence, but instead of using words, which then have to be tied to a language, is there a way to do it just using symbols? Does that make sense? And so they do. And that's all an equation is. An equation is a way of describing a relationship, but instead of using words, we just use numbers and letters. Does that make sense? Okay. So I want to talk through this, because the way we graphed this here was I said, start on this axis, right? Start here and go to 1. That's the first thing we did, right? We started there and we went up to 1. What do we call this axis? Do you remember what we call the one that goes up and down?
The Y,
Very good. We call this one the Y, and we call this one the...
X,
Good. Okay. And by the way, those letters don't mean anything. Somebody just picked them. In fact, it was a guy named Rene Descartes. And he just picked it. He just said, we could use X and Y. And everyone went, yeah, okay, cool. And like now, 400 years later, we still do that. But like it wasn't anything special. He was just like, well, we got to call them something. Just like when your parents named you, right? You got to call the kids something. Not going to call them like, well, that's my first kid. Like they need a name. So you name them. And that's all this is. They're just names. We call the one that goes up and down Y, the one that goes left and right X. Just names. So what we'd say is, okay, if we had the same thing where we're going to start at 3 and then we're going to go up by 2 and over by 4. That's what this says here, right? Start at 3, go up by 2 over by 4. If we were graphing this, don't do this, but if we were graphing it, we'd go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we'd say, okay, I need to start at 3, right? So I would start here, and I'd go put a dot there, right? And what do we call this axis again?
the Y,
We call it the Y. So the first thing we'd do is we'd go to the Y, and we'd put a dot on 3. Cool. Make sense? All right, so here's what we're going to do. In an equation, we're going to say, go to the Y, so Y equals. That literally means start on Y. And where are we starting?
3, so Y equals 3.
Y equals 3. Beautiful. Makes sense, right? Start on the Y, go to 3. Excellent. Now, this one, does it go up or down?
Up.
Up. So how do I say go up?
Up, plus, right?
Plus. Plus means get more. So plus means go up. If I were going down, what would I put there?
Negative.
Minus. Does that make sense? So if the line is going up, to tell the equation that, we put a plus. And then how much do we go up by?
2,
And then we have to go over by
4.
4. Okay, so this says start at 3, then go up by 2 for every 4 you go over. Up by 2 and over by 4. Does that make sense? Awesome. And then, are we going up by 2 and over by 4 just once? That's not how a line works. You can always keep doing it, right? Up by 2 over by 4, up by 2 over by 4. You do it over and over again. How many times? Well, as many times as you want. You can just keep going up by 2 every time you go over by 4. And every time you go over by 4 on, what do we call this axis?
The X.
The X. So we say, start 3, go up by 2 and over by 4, X times. As much on the X axis as you want. As many times as you want, you can go up by 2 and over by 4 on the X axis. And that's what this says. Go to your Y axis, start at 3, go up by 2, over by 4, and then the X means we're doing that on the X axis. We're doing it over and over and over again. And that's how you make an equation. So let's just label this then. This says start at Y. So start on the Y axis. This says start at 3 on the Y axis. This says go up by 2 and over by 4. And then the fact that we have an X here says it's being multiplied by X, it's being multiplied by some number, means you can do that over and over again. Yep. Yeah, can you wait literally just 1 minute? Because it's okay if you can't, you can just go, but I've literally got one more point to make, and then you'll know. And then you can ignore me. Now, there's another thing that makes this a little bit more annoying. I like this. And if you're giving me an answer, give it to me like this. I like this. This to me makes so much sense. Go to the Y, start here, go up and over by this, do it over and over again. That's the equation. That's a great answer. It's not a wrong answer, it's a right answer. It's a really good answer. There's something really annoying. Ready for this? For whatever reason, most mathematicians, when they write this equation, they do it just a little bit differently. They switch 2 things. And it's annoying, but you're going to see it like this more often. So ready? So this is one way. This is way number 1. And it is totally correct. And if I were you, I would always do it this way because I like it better. This, to me, I can just talk through it. Start here, go there, over and over again. But just so you know, there's a second way, which is all the exact same information. It's exactly the same. It's just a little less logical. It makes a little less sense to me. I don't love it. The other way to say this would be to say, on the y-axis, first they tell you how you're going to change. Then they tell you where to start, which is kind of weird, right? I don't love that. To me, you should start at the start. That makes a lot of sense, right? But for whatever reason, most mathematicians, they actually do it in the opposite order. They say, this is how you're going to move. By the way, start here. Which, does that feel backwards to you? It feels backwards to me. But that's how they do it. So the way most math teachers would teach this is they would say, okay, on the y-axis, you're always going to go up by 2 and over by 3, 4. Up by 2 and over by 4, over and over again. And then don't forget to start at, where did this one start? Good. So they give all the same information, they just switch it. And that's more common. So if we read this, we would say, on the y-axis, you're going to go up by 2 and over 4. And this would say you're going to do that over and over again. And then this one here would tell you start at 3. And there's other math reasons why they put the number you start with at the end, and they actually do make good sense once you know that math, but I still don't prefer it. If it were up to me, we'd do it the way above. You can always, in this class, do it both ways, and you'll get the exact same answer. They are the same answers. The same set of instructions, it's just saying it 2 ways. But out in the wild, when you just come across an equation, this is pretty much always how they will give them to you. So just like last time, I've given you a little practice app down here where it's going to give you the information, and you just need to make an equation out of it. So let's look at the one here. I'm going to press new equation a few times. Now you can go. Yep, go nuts. So let's take a look here. What does this say? Write an equation for a linear relationship with an initial value of
5.
And a slope of?
Up 3 over 2.
Beautiful. So going up 3 over 2. So what we're going to say then, when we go to punch this in, and I need a keyboard. Do I have a keyboard on here? I do. Is what? I said I need a keyboard. Oh, you're okay. Give me a sec. Oh, there it is. Okay. Oh, now you want to work. I see how it is, keyboard. No, I'm going to use this one. Okay. So we always start by saying we're on the y-axis. In other words, we're talking about how high we are. So these always start with y equals, right? Y equals. And then let's do it this way. Let's start with up and over. So on the y-axis, for this line, we're always going to go up by
3.
And over by
2.
And if you want to put the plus for up, that's okay, that's right. Often the plus just gets left out. I'm going to leave the plus up, but you can do it either way. And then how do we say do that over and over again? We don't just go up by 3 and over by 2 once. We do it over and over and over again.
X.
We put an X there. And then we say don't forget to start at?
5.
Great, so how do I say that?
You just put a plus 5, right?
Beautiful, exactly right. And so to read this out loud, it says you're going to go on the y-axis. You're always going to go up by 3 and over by 2. You're doing it over and over again, and you're not going to forget to start at 5. And then I can click, check answer, and it will give me the right answer right there. Does that make sense? Awesome. So I want you to take a few minutes and just try a few of those. All right, I'm going to check in with Miss Malloy because she needs something there. But just honestly take a few minutes and just make sure you can do both those things. Make sure that you can plug it onto a graph, which you guys are doing awesome with, and make sure you can also write it as an equation. And if you can do those 2 things, you're going to be golden. You're going to be so good, and you'll be able to go back and forth between one from the other. So I'm going to give you 5 minutes. Just play with that. All right, I'm going to check in with Malloy, and we'll come back and we'll do the last two things we're going to do with it, which is not a big deal. All right? Cool. How are we doing? Was anyone able to get some of these to work? We feel like, is that all right? Any questions?
I've done two.
And they feel good?
Yeah.
I love it. See, you guys are so good. Oh, you're hired. Okay. So here's what we're going to do. I'm not going to take tons of time. In fact, I can't, which is perfect. This is great. So we got 8 minutes. I want everyone to go to B if we can. Which is B is exactly what we just did. Exactly what we just did, but you got to go the other way. Oh, you got to go the other way. What if I give you the line? Can you describe the line to me? Let's look at this line right here. It's a happy looking line, isn't it? Well, this line, where does she start? Where does this line start? Yeah.
3.
Sorry?
3, but it starts at 4.
Beautiful. Bingo. Fantastic. Right there. So we call that another term we use sometimes. Sometimes we call it the initial value, the starting value, and sometimes we call it the Y-intercept. So I'm going to say 4. Yeah.
Where is that?
Oh, I'm sorry. This should be in 3.1B.
Okay.
Sorry, did I go too fast? I get excited. I do. I get very excited about math. Does that make me weird? Am I weird? I'm a little weird. Anyway, that's okay. Okay, so this one starts at 4. Now, is this line going up or is it going down?
No.
Beautiful. So when I go to put the slope in, how am I going to say that? How do we say down? Negative. Okay, and then can we count here? Where's another good point? Because I see a lot of crappy points. Crappy, not good, garbage. See how that's a nice one? Why is that a nice spot? What do I like about this spot for counting?
Because it's where the lines are.
Bingo. You always want to try to find points that are perfectly on corners, because then you don't have to guess. You know what I mean? If I went here, I'd have to be like, what is that? 0.2, 0.3? I'm guessing. But here, it's right on the line, right? So now let's just count. You said we're going down, so I put a negative sign. Awesome. How much are we going down by? Well, 1, 2, 3, 4, 5. Did I count that right? Let's do it again. 1, 2, 3, 4, 5. Looks good. So I'm going down by 5. How much do I have to go over by? 1, 2, 3, 4. Does that make sense? And so when I put it in, I'm going to say, okay, the y-intercept is 4 and the slope is 5 over 4. Now, this does something that you don't have to worry about, but I had it do it because I want you to see this. I like fractions, but just so you know, sometimes they don't give you the slope as fractions. They're going to turn it into a decimal. But that's okay. Don't worry about it. Don't worry about it. You can still work with yours. So for this now, we'd say on the y, was it changed by? Well, we said go down by how much?
5.
And over by how much?
4.
Nice. And then to say do that over and over again, I need to put in an x. And then where did this start?
Plus 4.
Good. And so in here I put plus 4, right? So there we are. And then there's supposed to be a check answer button. Where's my check answer button? Okay. You might have to give me 2 minutes to make the check answer button appear again. I don't know why it's not there. But when you come back from break, it's sure going to be there. Why? Where'd it go? That's so annoying. Okay, there's a check answer button that goes right here.
It's not there for me either.
Yeah, I'm going to fix that right now. But does that make sense? And that's all you have to do with these. Find the y-intercept, but that's okay. Don't worry about it yet. Wait till I get the check answer button because I want you to be able to check your work. And I just know I accidentally made it invisible. Whoops. It's a thing I do sometimes. I'll make it visible. And then this one here goes the opposite way. If that one gives you the line and says, make me the equation, this one gives you the equation and says, make me the line. No problem. Same thing. With this equation, let's do this one. This is a good one. Where should I start if this is my equation? Where should I start if this is my equation? Yeah. Nice. So I'm going to take this and I'm going to put it at 4. Does that make sense? And then this says what? Is it going up or is it going down?
Up.
It's going up. And so I might have to scroll around, which I can do. And how much am I going up by?
5.
So I go up by 1, 2, 3, 4, 5, and I go over by 1, 2, 3, 4. And then see how this one has a check answer button, not like the stupid last one. Then I click check answer, and if I've done it right, it'll be there. This is just like last time, but instead of giving you words, it gives you the equation. If you guys, by the end of today, and you're totally going to be able to because you're killing it, if you can go between sentences, equations, and graphs, any which way, I give you one, you can give me the other two, you will be fantastic. Does that make sense? You'll be just killing it. So for both these pages, for B and C, it just asks you to try 5 times, and every time you get one right, take a screenshot of it and paste it in there. And I think you guys will be great with that. But just, you're going to have to, when you come back from break, which are going on shortly, I'll have B fixed. I don't know why the check answer disappeared, but that's an easy fix. I can do that real quick. So, yeah, you guys got a break, and you can start early if you want. All right, you can have some food, have a drink. You can go outside because it's first break, which is kind of nice to get some fresh air. So, yeah, and while you do that, I'm going to figure out why that disappeared. All right, GeoGebra, what are you doing to me here? My resources. That's the one. And we're going to say edit it. Edit. And new line is there. But where is... Here, I'm going to... You guys want to see the magic? Here's the app, and let's see, so there's the code on that button. Good, we like that. And then when we put the equation in, that is filling in G. So then we should have y equals, like, what's this? 1 over 1x plus 4. But you just have to press enter. Well, I don't want you to press enter. I want it to be, okay. Okay, set visible on screen in view. I'm going to call it G, and we're going to say 1, and we're going to say plus. Nope, we're going to say true. And then I'm going to have that new line scripting. Okay, there we go. Y equals 2x plus 4. No, but I won't. Huh. right there, I promise. If you leave the page and come back, it should now have a check answer key to it. And actually, there's one more thing I want to do. Sorry. I want you to be able to. Okay, good. Ooh, sorry, excuse me. All right, if you leave the page and come back, that one should be fixed now. Which means just, yep.
How do I do this picture thing?
Ah, no problem. Hold the Windows key, the Shift key, and the S key, and then just drag around what you want. So Windows Shift S. Yeah, draw your rectangle. Beautiful. And then when you go down, when you go into here, where it wants you to paste it, just Control V. Nice. Yep, that's all.
So it's
Windows Shift S. Yep. So yeah, if you go through A, B, and C, and then you really will be done for the day. And just to show you, so if I can have your attention up here, I know you guys have already had to pay a lot of attention to me, but whatever. Captive audience. So now if we look on B, getting the equation of a line, you can say new line, new line, new line. And so like, let's, this guy looks happy. Okay. So if we looked at this one right here, where does this thing start? Oh, I'm sorry. Oh, you're not even looking at the right screen. Sorry, I'm sorry. Okay. Okay, let's look, I like that one. Okay, where does this one start? Yep.
5.
Very good, so where do I put that?
The Y-Intercept.
Yeah, good. What's another word we could use for Y-intercept? Sometimes we call it the Y-intercept, sometimes we call it
Initial value.
initial value, sometimes we call it the starting value. Cool. What's the slope on this guy? Because I kind of like that spot there, right? I like that spot. I could also use this one. They both be right, but I'm going to use that one. So is this going up or down?
Down.
How do I say that?
Negative.
Cool. And then how much down? How much down?
5, I think.
Are you going to this spot?
Oh, I know that's.
Because you could do that. So 1, 2, 3, 4, right? Cool. Okay, down 4. And in that case, we're going to have to go over 1, 2, 3, 4, 5, 6. Right? Cool. Nothing wrong with that. Oh, I screwed up. -4 over 6, or was it 5? 4, right? Yeah. Cool. Nice. We'll do that. You could also have gone to this point and said 2 and 3. Both right answers. Not one is not more right than the other. And when we go to put that in, we'd say y equals. We said we're going down.
Y equals negative 4. Or
Yep. 4 over
5.
Was it 5?
Yeah, I think it was.
It was 1, 2, 3, 4, and then 1, 2, 3, 4,
Oh, no,
5, 6. Yeah, so negative 4 over 6. And then where did it start?
At 5.
Yeah, plus 5. And when we check it, oh, I screwed something up. Oh, I forgot. What did I forget? I forgot something. I forgot the x. Oh, boo. Right? And by the way, they use 2 and 3, but 4 and 6 is just as good an answer, right? We said go down 4 and over 6, true. They said go down 2 and over 3, true. But I forgot to put the x. Oh, I'm fired. But that's okay, you can do another one. And this one we could say, okay, it starts at negative 1. This one we're going up by 2 and over by 1, so up 2 over 1. When we make an equation, we can say y equals up 2 over 1 x, and then this starts at negative 1. And we can check the answer, and bingo. See the red comes there that shows me I'm doing it right, and it shows me the equation right there. Cool? All right, carry on, guys. You're doing great.